All right, so this is section 1.3, Introduction to Experimental Design. And here's basic guidelines for planning a statistical study. Number one, first identify the individuals or objects of interest. Number two, specify the variables as well as the protocols for taking measurements or making observations. Number three, determine if you will use an entire population or a representative sample. If using a sample, decide on a viable sampling method. Now, we talked about sampling back in section 1.2, by the way. Number four, in your data collection plan, address issues of ethics, subject confidentiality, and privacy. If you're collecting data at a business, store, college, or other institution, be sure to be courteous and to obtain permission as necessary. Number five, collect the data. Number six, use appropriate descriptive statistics methods, which is covered in your text in chapters 2, 3, and 9, and then make decisions using appropriate inferential statistics methods, chapters 7 through 10, for example, hypothesis testing or confidence intervals. Number seven, finally note any concerns you might have about your data collection methods and list any recommendations for future studies. So one of the issues that you need to consider is whether to use the entire population in a study or a representative sample. So if we use the data from the entire population, we have what's called a census. So in a census, measurements and observations from the entire population are used. If we use data from only part of the population of interest, we have what's called a sample. In a sample, measurements or observations are from part of, or measurements or observations from part of the population are used. When gathering data for a statistical study, we want to distinguish between observational studies and experiments. So in an observational study, observations and measurements of individuals are conducted in a way that doesn't change the response or the variable being measured. In an experiment, you have what's called a treatment. A treatment is deliberately imposed on the individuals in order to observe a possible change in the response or variable being measured. For example, some kind of medical treatments, for example, medications. Take a look at example 4 in this section. Statistical experiments are commonly used to determine the effect of a treatment. However, the design of the experiment needs to control for other possible causes of the effect. For instance, in medical experiments, the placebo effect, which some of you may, or maybe all of you have heard of before, is the improvement or change that is the result of patients just believing in the treatment, whether or not the treatment itself is effective. The definition of the placebo effect, or when it occurs, I should say, the placebo effect occurs when a subject receives no treatment, but incorrectly believes he or she is in fact receiving treatment and responds favorably. To account for the placebo effect, patients are divided into two groups. One group receives the prescribed treatment. The other group is called the control group, receives a dummy or placebo treatment that is disguised to look like the real treatment. Finally, after the treatment cycle, the medical condition of the patients in the treatment group is compared to that of the patients in the control group. A common way to assign patients to treatment and control groups is by using a random process. And again, we looked at selecting random samples in section 1.2. This is the essence of a completely randomized experiment. A completely randomized experiment is one in which a random process is used to assign each individual to one of the treatments. Take a look at example 5 in this section in your textbook. It's difficult to control all the variables that might influence the response to a treatment. One way to control some of the variables is through something called blocking. A block is a group of individuals sharing some common features that might affect the treatment. In a randomized block experiment, individuals are first sorted into blocks, and then a random process is used to assign each individual in the block to one of the treatments. So what you see before, I'll let you look over this on your own. This is a sample of a randomized block design. And so notice, without going into it in detail, you have a patient, it's been divided into men and women. And then within those groups, you separate it into group one. Let's take a look at the men branch here. You have random assignments. Some of them are in group one where they actually receive laser holes in their heart for this particular treatment that's cited here. And in group two, there are no holes in the heart, and then they compare pain relief. And the same thing is done for women if you take the second branch down here. So this study cited in example 5 has many good features of an experimental design. I'll let you look over that yourself. And here are some of those features of an experimental design. You have a control group. They receive the dummy treatment. You use, let me go on and finish that. Enabling the researchers to control for the placebo effect. In general, a control group is used to account for the influence of other known or unknown variables that might be an underlying cause of a change in response to the experimental group. Such variables are called lurking or confounding variables. They also use randomization and replication. I'll let you read over that yourself. Sometimes our goal is to understand the cause and effect relationships between two or more variables. So such studies can be complicated by lurking variables or confounding variables. Lurking variables, by the way, will be mentioned again later on in the text when we're doing various types of hypothesis tests. So a lurking variable is one for which no data has been collected, but nevertheless has influence on other variables in the study. Two variables are confounded when the effects of one cannot be distinguished from the effects of the other. They might be part of the study or they may be outside lurking variables. Take a look in your textbook at guided exercise 5. And I'll let you read over this yourself about surveys. Notice also that they talk about the Likert scale, which is commonly used in surveys. I will go down here. A number of issues can arise when using a survey. For example, number 1, non-response. Number 2, truthfulness of the response. Number 3, faulty recall. Number 4, some kind of hidden bias and based on the questioning, for example. Number 5, vague wording. Number 6, interviewer influence. Number 7, voluntary response. So take a look in your textbook at potential pitfalls of a survey. And then take a look at the choosing data collection techniques. For your homework in here, just take a look at problems 7 and 9. And all of your odd problems, by the way, you can click on it and get the answers to so you know if you're on the right track or not.